Hey everyone, welcome back to Ameta Academy. Today we're talking about a category of camera that changes the conversation from watching footage to detecting risk earlier. A lot of security cameras depend on light, scene detail, and clean visual conditions, but real job sites are not always clean and predictable. You get darkness, fog, glare, smoke, open perimeters, and situations where you need to detect something before you can clearly identify it. That's where thermal comes in. And specifically today, we're covering two AI-based bispectrum thermal cameras that combine thermal detection and visible imaging in one device. So you're not piecing together multiple products to build the one solution. We'll break this down using four parts: credibility, reliability, value, and pro tips for installers and integrators. Let's start with what these cameras actually are. Both of these cameras are AI based models that use single IP bispectrum cameras. That means the camera gives you both a thermal stream and optical stream. On the thermal side, both models use a vanadium oxide uncooled focal plane detector with a 256 by 192 resolution. On the visible side, both give you a 5 megapixel optical image 2592 by 1944. They also support dual image fusion, so you're not limited to choosing one mode or the other. And this is the right place to use the classic thermal language. These cameras do not rely on visible light that the way a standard camera does. They detect differences in heat energy. So in the field, the first question is no longer how well lit is the scene. The question then becomes, is there a heat emitting target present and where is it moving? That is a major upgrade in detection logic. Now, now both models support three temperature measurement rule types: spot, line, and area. They both have AI functions on both thermal and optical streams, temperature exception alarms, and fire prevention alarms, a temperature range of -4 degrees Fahrenheit to 1022 degrees Fahrenheit. They both have built in audio and red and blue flashing lights. So, these are not just specialty cameras for just seeing heat. These are cameras built for detection, verification, alerting, and temperature based event handling in one device. Now, let's separate the two models. The CAM TP3165W 32 is the turret version with a 3.2 thermal lens and a 3.6 optical lens. That makes it more natural fit for a wider area coverage and a shorter to mid-range distances. The CAM TP3765W 70 is a bullet version with a 7mm thermal lens and an 8mm optical lens. That makes it a stronger fit when you want a tighter field of view and a more reach down a fence line, yard edge, corridor, or open perimeter. Now, let's talk about where these actually make sense. The first use case is perimeter protection. If you're protecting an outdoor boundary, yard, lot, construction site, or industrial edge, thermal gives you a real advantage because it's designed around detection, not just image quality. In other words, you're looking for a presence of a person, vehicle, or a heat source even when visual conditions are poor. The second use case is critical outdoor environments. When the customer has fog, darkness, glare, or inconsistent lighting, a traditional image first camera can become less dependable for early detection. A bispectrum thermal camera gives you thermal awareness plus the visible stream for context and follow up verification. Now, the third use case is heat monitoring and fire prevention related scenarios. Because these models support spot, line, and area temperature rules, plus temperature exception alarms and fire prevention alarms, they're not just for intrusion detection. They can also be positioned as part of a solution around equipment monitoring, overheating awareness, and high risk areas where temperature abnormalities matter. And the fourth use case is active response. Because these cameras support built in audio and red and blue flashing light alarms, you can position them not just as passive sensors, but as part of a more immediate response strategy. Now, let's get into the value, because this is where a lot of deals are won or lost. In the market, you generally see three buckets. At one end, there are premium solutions with very strong performance and strong reputation. But for many jobs, they are priced at a level that makes them hard to justify unless the site is extremely high risk or highly specialized. On the opposite end, there are lower cost solutions that can look attractive upfront, but they often lean more heavily on image based performance, a lighter solution depth, and fewer practical advantages once the system is actually deployed in the field. And then there are products that sit in the middle in price, but they make you build around their limitations with added lighting, more tuning, more hardware, and more callbacks. This is where our AI base creates a strong value story. You're getting thermal detection that does not depend on visible light, a 5 megapixel optical stream in the same device, AI on both streams, dual image fusion, temperature based rules, audio and flashing alarm capability. So the value is not just this camera costs less than something else. The value is fewer add ons, less system patchwork, more dependable detection logic, and a more complete solution in one single product. That matters because installers and integrators do not make money on spec sheets alone. They make money on systems that are easier to position, easier to deploy, and less painful to support after the job is done. So the ROI story becomes not just camera price, but total solution value. If you can give the customer early detection, lower nuisance events, built in alerting, and thermal plus visible in one unit, you are selling a stronger outcome, not just a cheaper box. So let me close with these three pro tips that actually fit these two models. Pro tip one: choose the model by scene geometry, not by mounting style. Do not start with turret or bullet. Start with the shape of the scene. If the job needs broader coverage closer to the camera, the CAM TP3165W-32 is the model to choose because of its 3.2 millimeter thermal and 3.6 millimeter optical lensing. If the job needs more reach with a tighter view and defined direction, the CAM TP3765W-70 is the way to go because of its 7 millimeter thermal and 8 millimeter optical lensing. So the first pro move is simple. Match the lens to the scene before you talk about housing style. Pro tip 2: sell fusion, not just thermal. Because both cameras support dual image fusion, do not present them as a thermal camera only. Present them as cameras that let the operator move from heat-based detection to better visual context in one camera. So apologies. So that makes it a stronger sales story than just saying it just sees heat. The real story is it detects with thermal and helps verify with visible imaging in one device. Pro tip 3: lead with the problem the customer is actually trying to solve. These products have a multiple angles, so don't use the same pitch every time. If the customer is worried about perimeter intrusion, lead with early detection and poor visibility. If the customer is worried about nuisance events, lead with a thermal based detection logic. If the customer is worried about safety or overheating, lead with spot, line, and area temperature rules, temperature exception alarms, and fire prevention related positioning. Same camera family, different business problem. That is how you keep the conversation solution based instead of product based. So here's the bottom line: the AI based bispectrum models are not just thermal cameras in a narrow sense. They are a single IP detection and verification tools that combine thermal sensing, 5 megapixel visible imaging, AI on both streams, image fusion, temperature rules, and built-in alerting features in one single device. Again, the CAM TP3165W-32 is a better fit for when you want a wider and shorter cover range, and the CAM TP3765W is -70, is the better fit when you want a tighter, longer range coverage. So if your customer needs more than just footage, if they need earlier detection, better situational awareness, and more complete response ready solution, AI-based bispectrum thermal camera is what they need. Now, I'm going to send you over to my guy Zach from Tech Squad. Zach?
Hello everyone. For today's demo portion, I'll be covering the setup of the thermal camera and also just a few other, covering such as like the AI, the fusion that you see here, the overlay, all the other, advanced features that are included with this specific camera. So the first thing we'll do here is, as you can see, it is a dual lens camera itself. You have one regular lens and then one bispectrum lens, which you would use for your fire smoke detection, heat detection, and measuring heat levels, depending on what you set up for your AI. So as you can see, you have both channels here. Then we can go into the remote setting. And the first thing I'll show you is the image settings. So for the first lens, which is just your basic, regular color view image, nothing too special with this one. You do have all of your basic settings, which you have on any other camera in our AI-based product line. But if you go and select channel number 2 here, you'll see it's our thermal. So the main thing that we want to focus on is the palette. So we go here to palette. This is where you can change your overlay. Like for example, the most common one that we see out there with thermal cameras typically is your white hot. So you'll see a black and white image, depending on the heat signature. Typically, the hotter the object is, they'll appear white in the camera view. But you do have a wide variety of different options to choose from. You can do green, the fusion with different colors. Yeah, there's many that you can choose from depending on your environment. So this, again, it really just depends on where you're installing the camera, the environment, and finding what works best for your setup. And then once you have that done, that's all set up, that's good to go. We can move over to the event settings. So just like Austin mentioned previously, you do have AI on both lens of the camera. So for the main lens, which is just your basic color image, we can do human and vehicle. That is the most common one used by installers and integrators for their projects. But since this is a more advanced camera, maybe you want to do something like loitering. Let's say you have it in a back lot using a thermal camera. You can enable loitering, do your loitering detection, so you can do up to 1800 seconds whenever the target or person or vehicle, whatever the case may be, is in your loitering zone for that specified amount of time. It'll trigger the deterrence on the camera. So you have all of the full AI suite for the first lens. Then moving into your thermal lens, the two main things that you want to focus on is your fire detection, which we can enable here. You could also change the sensitivity. So the sensitivity would just mostly be based on the distance. So if you have objects that you want to monitor that are further away, you will want to increase the sensitivity up. If it's a little bit closer to the camera, then you can decrease it. Again, just all depends on the placement. The other thing that we'll want to take a look at, which I would say is the most important, is your temperature measurement. So we can go ahead and enable that one as well. And then here, all of these settings are mainly like your on-screen displays. So you can display your temperature information on the stream, display your max temperature that you set, your minimum temperature, the average, spot temperature, and then you have more advanced settings here. So you could change your distance in feet, temperature range. You have here two different options. So by default, it's in Fahrenheit, and then you can change it to Celsius and Kelvin. And then another thing is the area. So what this basically is, so if we click on add, we can enable a specific targeting zone. So we can click on enable. You can do a point. So what that means is you just click anywhere on the screen and it'll monitor that specific target point that you have set. Another thing you can do is align. So anywhere across this line, let's say it's like a factory assembly line, and you want to monitor that specific zone, it'll do that. And then the other option is area. So let's say we want to monitor these cars here. Let's see. So you click your first point, and then you drag it around the cars. So now we can do that. And then you have your zone set, and you see we have emissivity. So basically what that means is the camera will measure how well a target or object, the surface radiates heat. So depending on how, again, the distance, how far it is from the camera, you may want to increase it or decrease it depending on, again, the distance. So that'll just give you the reading based on how the heat is radiating off of the surface of these cars, for example. and then you also have the distance as well. So we can go ahead and click on save. And then as you can see, we now have the temperature bar on the right side. So you have your maximum temperature and your minimum. And then if we go back into the live view, you can also see it appears on the regular lens as well. So does give you a max temperature that reading that was recorded in this area, a minimum temperature reading in this area, and then the average temperature reading. And you can do multiple points as well. It's not tied to just one specific one. So you can do, if we go back to it, you can do, let's say ID number one is this box, add another one, and you want to do a point area. So let's say we want to measure the temperature of the road here. So you can click on there, click save. Now you'll start getting temperature readings of the road, and then we can do a third one. Let's just say we want to do a line reading. So click on line, save it, and you have that reading there as well. So all of these points can be customized and configured to however you would like. And then you have your alarm linkage. So you can set up your deterrents as well. So your notifications, which is, again, we talked about in our previous episodes, which are your webhooks. You have your sirens and your warning lights. And for those asking, the camera can function standalone. So all of this AI for the heat detection, smoke and fire, image sensing, getting your temperature readings, all of this can be done directly on the camera. You can just put an SD card in there and deploy it for standalone. And that would conclude today's demo portion for the thermal camera. So we'll go back to you, Austin.
Now we're just gonna do a live Q&A. So if you can, put your questions down in the comments in that little live stream box there, and we'll get to it. Yeah, so we have a question here. What kind of projects would you use these cameras? Could you share a project done with these cameras? Yeah, so I had a customer actually use these projects for surveillance reasons because they have a lot of brush and a lot of like unclear visible um, area where they need to get coverage in a perimeter. It was actually a real large area where there's a lot of bush, but there's people coming around, so he wanted to make sure that no one's going through the bushes. And he used the thermal camera at white hot because, bushes are dark and they're cold, and a human is going to be really white hot and visible. So it's really plain to see in a bush or in a brush or fog or anything like that when you have that heat signature come white hot into that visible area. And then for context, he can see the actual live view, so you can actually compare and contrast the white hot versus what you're actually seeing in the live view of the visible one. So it gave him a great benefit. The client was super happy, kind of really impressed that this one camera can do two channels at the same time and still see heat, and you can still see that visible guy. So it's a really unique thing. If you have a guy that's you know has a large area, maybe a lot of brush or something like that. Think of like hunting scenarios. They use white hot all the time to see animals. So think about that in your upcoming projects that really are high risk or something like that need a lot of visibility, but they don't have a lot of clarity in the actual scene.
Yeah, I'll also add on to that. Another good use case would be like recycling facilities or even like the trash facilities. So whenever, the trash, the crew, they pick up your trash cans, they take them back to their facility for processing. What happens a lot of times is people throw away lithium batteries. So there's a lot of fires, and obviously they have their protection systems in place for the fires, and they're prepared for that. But something like these cameras can use the smoke and fire detection as an early alert because the operators may not see it right away. So the camera will be able to pick that up and alert them whenever there is a fire or smoke detected in those type of facilities.
Sure. Any more questions? We'll take a moment here, let them populate. Hope everyone's having a great day, by the way. There you go. We already have a person for exact use.
Yeah, that's a perfect use for these type of cameras. That I know you mentioned the hotspots light up really well. And yeah, you can use the image fusion and the overlay to really detect those spots where, a small fire may pop up or just before it gets out of control. And they can easily manage it using the cameras, the thermal on it. Yeah, so installation for the cameras. So the installation will just be like any other camera. The installation I wouldn't say is too difficult. You can use one of our back boxes if needed. It's very simple, just the screws to mount it onto your surface. And then the rest of it is more of the configuration side. But I would say the installation for the camera is very simple, and it's like just like any other camera. There's nothing difficult about it, nothing special that needs to be done, no special brackets or anything like that. Yeah, and as you can see, Austin is showing the cameras and what they look like.
Just like you would any other camera.
Yeah, so I see another question. Client had a seat warmer on a snowmobile that caused a second-degree burn. Use thermal camera to pinpoint an exact hotspot and temp. Yeah, that is also
Yeah.
another good use case. Using the camera, you can find exactly where it might be just an exposed wiring on the seat warmer, and that caused it to, obviously burn the person. But that would be another good use case. You can find, exposed wiring, hotspots on many different types of equipment.
I have a question, Zach.
Yeah.
I'm most likely going to get this during my sales call, but what if you add these cameras to a third-party system? Is it possible? What would you be able to see?
Yeah, so when adding these cameras to a third-party system, like I mentioned, the cameras can function standalone. So you won't be able to configure the AI or the temperature readings or anything like that through the NVR. But if you set up the camera beforehand, do all your pre-configuration, you can add it to a third-party NVR. The limitation would be on the third-party NVR if you can add both channels. So we did a test on a Dawa NVR, and we were able to add both channels to it, as well as have all the screen overlay and everything like that, because it uses the Edge AI. So nothing needs to be done from the NVR side. So again, it really just depends on the type of NVR you're using, if it'll accept both channels. But again, it does support the main temperature readings, overlays, everything like that, which is done directly from the camera.
Awesome. All right, any more questions here? Okay. Seems like we're all good here. I want to thank everyone for joining us today. Thanks for tuning in. Please hit that like button, subscribe, and tap the bell to never miss our Friday live streams. Take care, and we'll catch you next week. Thank you.